Good morning, juniors. Hope you're doing fine today. Today we're gonna see electronic assignment 16, which is piecewise functions. We're gonna learn what this concept is about. For the ones who have math with me, which is a vast majority of you, this is a concept that we have already covered a little bit, and so this is gonna be kind of a review for you. So, the objective for today's class is only one: interpret and graph piecewise functions. Okay, so let's begin by defining what a piecewise function is. It says, a piecewise function is a function that has two or more equations for different intervals of the domain of the function. Okay, we're gonna see that in some examples later on. Let's do this investigation now. It says, Robin starts a business making fishing rods and has to produce a report at the end of the year to show his stakeholders. This table was included in his report and shows the number of rods made, which is a variable X, and the total production cost in dollars, which is a variable Y. So there we have amount of rods and the production cost. So it says, number one, show this data on a scatter diagram, and number two, draw a line of best fit of your scatter diagram. In order to not waste too much time, I have already done that here. This is the scatter plot with the line of best fit. And okay, so in the x-axis we have the number of rods, and in the y-axis we have the production cost. Okay, so you see that this is a normal scatter diagram with a line of best fit. So then it says, number three, comment on how well the line fits the data and how accurately you could use it to make predictions. So pay attention at number three. I already have all the answers for this investigation to avoid wasting too much time. So it says, once again, comment on how well the best fit line fits the data and how accurately you could use to make predictions. And here it says the answer. Earlier points are below and later points are above the line. Not a good fit for prediction. Okay, so what this actually means is that maybe there's another line of best fit or a set of line of best fit that could fit this information better. For example, if this earlier points that we have here, you see that they kind of follow a different pattern from the ones up here. You see that if I kind of do a trend line here between the lower points, I'll get something like this. And then for the upper points, I can get something a little bit steeper, right? Maybe something like that. Okay, so you see that these two sets of lines make a better or serve better for prediction purposes. Okay, so let's keep on reading this. Number four says, explain how this information might cause you to conclude that a single regression line is not enough to best represent the relationship between the number of rods and production cost. And here's the answer. It says, when Robin produces less than 50 rods, he uses one machine and one regression line models a relationship. When he produces more than 50 rods, he uses two machines, and so a different regression line is needed. So this is a supposition, right? But this is something that normally occurs in real life. Whenever we produce something, the higher production requires at least one extra machine, right, for production. And when that occurs, logically, our regression line changes, right? The production changes a lot when we implement more machines to the production system, right? So maybe that is what is happening here. Okay, as more machines are introduced to the system, then the line becomes steeper because we're able to produce more rods with less money, right? It takes less time. Then it says, number five, what is a piecewise linear model? What we just said above, it's a graph which has two different straight lines for different values of x. Then number six, when can piecewise models be used to represent bivariate data? And here it says, Piecewise linear models display the situation where one single equation of a line does not fit the entire set of data points. So that's when we should think about applying piecewise functions, okay? Number 7, the question for 7 was use technology to find one regression line for 0 to 50 rods and another for 50 to 100 rods. Plot the piecewise regression lines on your scatter diagram. And then number 8, comment on whether the piecewise model or the linear model better fits the shape of data. Okay, so let me show you how to find these two equations using our calculator. We already know how to calculate the green equation, which is just by plotting the points in the calculator, menu statistics, and then calculating the regression line. But let me show you how you can do this for a piecewise function. So give me a second, I'm gonna record the calculator here. So now, okay, so this is a calculator. Once again, if we go to menu statistics, you may follow this using your calculators as well. Let me erase all of this information over here. In order to make the piecewise function, what I should do is I need to first plug in the values of x and y for the first pieces of information, which were the from 10 to 50 rods, right? So let me write that information that we had in the exercise. Values of x were 10, 20, 30, 40, up to 50, okay? That's where we cut the first regression line. So the respective values of y were 100, 120, 140, 144, and finally for 50 we have 145. So for this first set of data, I'm going to go to calc. You already know the steps: calc, reg, x, ax plus b, okay? So you click on ax plus b and we get the equation of the line for the first set of data, which are the early pieces of information, okay? So just a second, let me write that in our information. So for 0 to 50 rods, the equation would be y equals 0.703 x minus 62.7. Okay, so that's the first part of the piecewise function. Then to do the second part, I will plot in the second pieces or the second set of data, and I'm gonna leave the point 50 and 155 because that's like a shared point between the two values. So let me erase this between the two lines, sorry. So if I plot in the second part of the information, we're going to start with 50, then 60, 70, 80, 90, and 100. Then if I plug in the respective y values, this would be 155, 195, 250, 275, 340, and finally 360. So once again, we do the same thing: calc, reg, x, ax plus b, and we get this second equation over here, which is what I'm gonna write right here. For 50 to the last value was 100, right? Yes, 100. The equation would be y equals 0.232 x 232x plus 13 point or 14.0, okay? So 14.0. Okay, so if we go back to the electronic assignment now, we're going to see that these are the two equations, okay? And this is what we call a piecewise function, okay? There seems to be something here that is not quite correct though, because I get a value of the slope here which is less than the value of the slope we had here. And it should actually be the other way around. This line is less steep than this one over here. That's what is kind of tricky here. Okay, but never mind. I'm not going to show you how to graph the functions for this one. I just want you to understand the concept for the piecewise function. So for the first set of values, we have this equation over here. And for the second set of values, we have this equation over here. If you draw these two, you should get something like this. But let me show you how to draw this using another example. I'm going to use one of this to show you how to plot using the calculator. Okay, so that's it for the investigation. Let's do the examples to make this clear. It says draw the piecewise functions. And for part A, you see this is the symbology for piecewise functions. It is f of x, that is, it's just one function, but that is defined within two intervals. It's x plus 2 when the value of x is less or equal than 1, and it's 4 minus x when x is greater than 1. That's how you read a piecewise function. And how do you plot this? Well, it's actually very easy. If I know that this piecewise function changes its function, this is the value of 1 is like my limit, right? Between both functions. So I'm gonna pick the values somewhere near 1, right? So if I make a table of values, I make from -1 to 3 in order to contemplate the limit, which is 1. And for any value that I pick that is less or equal than 1, I'm going to evaluate it using this function over here, which is the green one over here. And for any value which is greater than 1, I'm going to use this function over here, which is the orange one over here. Okay, so let's do this. For x equals -1, I'm going to look at the green one, right? Because it's less or equal than 1. So -1 plus 2 gives us -1. Then for 0, I'm still looking at the first function. 0 plus 2, that's 2. For 1, I'm still looking at the first function because it's less or equal than 1. So 1 plus 2, that's 3. Is this correct? -1 plus 2. Sorry, -1 plus 2 is actually +1. There you go. So 1, 2, 3 are the values over there. Then for x equals 2, I'm going to be looking at the second function because x is already greater than 1. So 4 minus 2 gives us 2. And finally, 4 minus 3 gives us 1. We also look at the other function, okay? So once we have these points, we're going to plot the points onto the graph. So -1, 1, that's here. -1, 1. Then we have 0 and 2, that's here. And finally 1, 3, that's right here. So you see that we're getting, all of these equations are linear functions, so we should get lines for each of this. So if we draw this, and okay, I'm going to draw this, it's going to go infinitely down because it's a straight line, right? So let me do it up to there. And you see that for x equals 1, I painted the whole point because the value for 1 is included in this function, right? The value 1 is included there. So let me write here 1. Then for the second equation, I need to plot the values 2 and 2. 2, 2, that's here. And the value 3, 1. 3, 1 is right here. So then we need to join the points and extend this as it is a straight line, okay? So this continues here and the green one continues down here. So this is what a piecewise function is about. For x less or equal than 1, it behaves this way, and for x greater than 1, it behaves this way. Okay, that's a piecewise function, and it's as easy as that. So let's see this example B. It says f of x is 2x plus 1 when x is less or equal than 2, and the function is 6 when x is greater than 2. What is this function? What does this function look like? This is a horizontal line, right? So when x is greater than 2, this is just a horizontal line at y equals 6, right? So let's draw this. So now our limit would be x equals 2, right? And 2 is included in the first function we have here. So for 0, we need to evaluate in this one. This would be 1, 2 times 0 times plus 1. Then for 1, 2 times 1 plus 1, that's 3. And for 2, 2 times 2, 4. 4 plus 1 is 5. Then for the rest of the values where x is already greater than 2, we would need to evaluate this using this function over here, which has no x, right? So independently from the value of x, this would always be 6 and 6 because we're talking about a horizontal line. Okay? So let's plot those values into our graph. 0 is 1, 0, 1 here. Then 1 and 3 is up here. Finally 2 and 5, 2 and 5, that's here. So once again, we're getting the equation of a straight line, right? So straight line, and this continues down like that. Okay, and then and for x equals 2, the function is included here, so we paint all of this value. Then for the orange line from x greater than 2 already behaves as a horizontal line at y equals 6. So pay attention here. Since the value 2 is not included, we're going to draw a circle without painting the circle. And from that onwards, we're going to draw a horizontal line, right? Which is true for all the values of x greater than 2, okay? So this is how this piecewise function looks like. We start at 6 for the orange line. We start at 6, but we do not paint the value of x equals 2 because x equals 2 is defined here, okay? Remember the definition of a function. For each value of y, there is a unique value of x, okay? That's why we cannot have 2 points defined for the same value of x here, okay? So that's how this piecewise function looks like. So you see that there's a small jump here. This is known as a discontinuity, okay? Finally, we're gonna see, I want to show you, I'm gonna use this second example in order to show you how to plot a piecewise function using your calculator. So let me go back to the calculator for a second. Now, if you see the calculator, let me go back to the exercise. Let me go back to menu. We want to graph the piecewise function. So you're going to go to menu graph, right? Menu graph. And let me erase this. I'm going to plot the 2 equations. The first one for part B was 2x plus 1. And the second one was just 6, right? Y equals 6. So you see that if you draw this, you're going to get, let me change the scale first. Shift V win. We're going to make it from the same as we had in the exercise, from -6 to 6 scale 1. And y goes from -10 to 10 scale 1 as well. So if we draw this, you'll get this, but you see that this is not drawn in as a piecewise function, right? Because we have all the first function here and all the second function here. But we want to limit this to their own conditions, right? The blue one is for x less or equal than 2, and the red one is for x greater than 2. So how do we do that? Go to exit, and then you go to a first function, and right after you've written the function, you're gonna write comma, and then bracket. Bracket is shift plus. This is something we have already seen in math, people. This is new for the statistics people. So inside the bracket, we're gonna write the domain where we want to draw this first function, and we want to draw this first function from at least -6, which is the first value we've drawn in the exercise, up to its limit, which is 2, right? So shift and minus to close the brackets, and that's it. Then for the second function, we want to draw this from, let's see, comma, we open bracket, from 2, which is the limit, to 6, which is the upper value that we're drawing, right? So we close this using bracket, and then you click on execute, and once again you click on draw. And now you see that you'll get the piecewise function that we drew, right? From -6 to 2, we have the blue function. Then you see that there's a jump here. And then from 2 to 6, we're getting the second function, which is a horizontal line. So this is how we draw piecewise functions using the calculator. So if we go back now to the electronic assignment, let's see this last example, which is an application of piecewise functions. It says in Tabodia, income is taxed at 20% for the first $15,000 an individual earns, and then at 30% for anything over $15,000. Draw a graph of tax paid for people earning up to $30,000. Okay, so in order to save time, I have already plotted the graph here, and basically what I want to show you is how we determine the equations of these lines given this information over here. Okay. So basically it says that we're charged 20% of taxes if we spend between $0 to $15,000, right? So if we spend 0, we will be charged $0 for taxes, right? So a known point of this line would be 0,0, right? $0, sorry, 0%, $0. And, sorry, it's actually $0, 0%, yes. And another known point would be 15,000, and we're charged 15% of that, right? Sorry, 20% of 15,000, which is 3,000, right? So another known point would be 15. You see that here it's written $1,000, so instead of writing 15,000, we're just writing 15. And if we spend $15,000, we're charged 20% of it, which is 3, right? Which represents $3,000, okay? So that's another point, which is right here. You see this is 15, and this value over here is 3, okay? So once we have those two known points, we're able to sketch our graph at point 0, 0, which is this, and at point 15.3, which is the one I just showed you, this. Once we have the 2 points plotted, we can sketch the line, right, with the use of a ruler. So the equation of this line, if you write the equation, it'll be, you can find the slope by, if you remember the formula, slope equals y2 minus y1, which is 0, divided by x2, sorry, minus x1, which is 0. This is 3 over 15, which if you simplify, it's 1/5 which is 0.2, which is the 20% we're talking about, right? So the equation would be y equals 0.2x plus c, but c in this case is 0, right? The y-intercept is 0. So this is just 0.2x. This will be the first part of the equation. Let me write that. This is for x smaller or equal than 15, okay? So this is the first part of the equation. Then for the second part, let me do that with a different color. We're charged 30% if we earn between $15,000 and $30,000. Okay, so two known points in this case would be, the first one is the same as we had in the previous, 15.3. That's a shared point. And the other one would be 30, if we earn $30,000. And we're charged 30% of that. That gives us, let me see, 0.3 times 30,000. That's $9,000, so 9 here. So we have two known points. Once again, if you calculate the slope, this would give us 9 minus 3 over 30 minus 15. This is 6 over 15, which if we simplify would give us, divided by 3, 2 over 5. And 2/5 is 2, is it? Divided by 3, that's 2, divided by 3, that's 5. Yes, we're getting 0.4. Shouldn't be 0.3. 9 minus 3. Yes, this is fine. Divided by 30 minus 15. 6 divided by 15. Yes, we get 0.4. Okay, so in order to do this equation we have here, we already have the slope, so this would be y equals 0.4 x plus c. In this case, we are going to have a value of c, because if you see, if we extend this line, the y crosses the line crosses the y-axis at a value different from 0. So we can plug in any value. For example, the second point, we will have 9 equals 0.4 times x, which is 30, plus c, right? So then we get the value of c, which is 9 minus 0.4 times 30. This gives us -3. So the equation would be y equals 0.4 x minus 3. This is for x greater than 15. So finally, the piecewise function will look something like this. Let me finish this by doing f of x equals, we open the keys and we have 0.2x for x smaller or equal than 15, and 0.4x minus 3 for x greater than 15. This is a piecewise function that models this equation over here, okay? So I hope this is clear now for you, juniors. If not, please let me know if you have any doubts, and we will try to solve them. Okay, so have a nice day, junior.